So let us read the unit 7, the P block elements. Here the objectives are written, but the main important thing is that about the P block. Diversity in chemistry in the hallmark of P block elements manifested in their ability to react with the elements of S block, D block and F block as well as the other elements. This means that so the P block elements actually manifested their ability to react with the elements. So they can show the reaction with S block, D block and F block as well as their own. Okay. They show reaction with S block, D block and F block as well as their own. Means they show reaction with the S block, means P block elements show reaction with S block with the P block elements show reaction with S block, then D block and F block and within themselves also. So in class 11 you have learned the P block elements are placed in group 13 to 18 of the periodic table. So in class 11 we have learned that P blocks elements are placed in group 13 to 18 of the periodic table and the electronic configuration is NS2 NP126. Okay, so the P block elements configuration is NS2 NP126. Their valency except helium, which has the 1s2 configuration. The properties of P block, like that of others, are greatly influenced by atomic size, ionization enthalpies, then the electron entrain enthalpies and the electronegativities. It means that P block elements like that of others means the P block elements like that of others means the other block elements like S blocks, D blocks and F blocks, they are also influenced by the atomic size, ionization enthalpy, electron gain enthalpy and electronegativity. So similarly P block elements also are they influenced by the atomic size, then ionization enthalpies, then electron enthalpy, then electronegativity. The absence of d orbitals in the second period and the presence of d or f orbitals in the heavier metals starting from the third period onwards having significant effects of the properties of the element. So this means that the absence of d blocks in the second period, so in second period there is no d block elements and D block elements or D and F block started from the third period onwards. In addition, the presence of all three types of elements like metals, metalloids and non-metals bring the diversity in the chemistry of these elements. This means that the presence of all three elements means the metals, metalloids and non-metals. The metals and metalloids are the non-metals are nitrogen and phosphorus. The metalloids are arsenic and antimony. The metals are bismuth and moscovium. Having learned the chemistry of elements of the group 13 and 14 of the P block of the periodic tables in class 11, we will learn the chemistry of the elements of the subsequent group in this unit. So in class 11 we have learned about the group 13 and 14 of the P block in class 11, and in this unit we will learn about the group 15 to group 18 elements. Okay, so that thing is written. Group 15 includes nitrogen, phosphorus, arsenic, antimony then bismuth and moscovium. So group 15s include the nitrogen, phosphorus, arsenic, antimony and bismuth and moscovium. As we go down the group, there is a shift from non-metallic to metallic through metalloids of the character. So as we go down the group, that means from nitrogen to moscovium, as we go down the group, there is a shift from non-metallic to metallic through metalloids. So at first we will find the non-metallic group, that is nitrogen and phosphorus, then we will find the metallic group, then at last we will find the metalloids group, and at last we will find the metallic group. Nitrogen and phosphorus are non-metals. Arsenic and antimony, they are metalloids, and bismuth and moscovium, they are typical metals. Nitrogen comprises 78% by volume of the atmosphere. So nitrogen, molecular nitrogen, it is the occurrence. So let us read about the occurrence. So the molecular nitrogen comprises 78% by volume of the atmosphere. In the earth crust it occurs as a sodium nitrate, and that is the child saltpetre, that is NaNO3, and the potassium nitrate, that is Indian saltpetre, that is KNO3. It is found in the form of proteins in plants and animals. So nitrogen is found in the form of proteins in plants and animals. Phosphorus occurs in minerals of the apatite family, and apatite family is formula is Ca9PO46 CaX2, and X here the fluorine, chlorine, and OH, that is the fluoroapatite family. And examples of fluoroapatite families is Ca9PO46.CaF2, which are the main components of the phosphate rocks. The phosphorus is the essential constituent of plants and animal matter. It is present in bone as well as the living cells. The phosphorus are present in milk and eggs. Arsenic, antimony, bismuth are found mainly as a sulfide minerals. Moscovium is the synthetic radioactive elements. Symbol is Mc, and its atomic number is 115. Its atomic mass is 289. The electronic configurations of moscovium is given here. So due to short half-life and availability in very little amount, its chemistry is not yet to be established. So its chemistry yet to be established, not established yet. So it will be established. So except for moscovium, important atomic and physical properties of other elements of these groups along with the electronic configurations are given in table 7.1. So electronic configuration, the valence electronic configurations of this element is NH2, NP3. The s orbitals in this element is completely filled and the p orbitals are half filled, making the electronic configuration extra stable. So the s orbitals of this element is completely filled, that is NH2. So this indicates that the s orbital is completely filled and p orbitals are half filled, that is NP3. So NH2 indicates the s orbitals. In s orbitals, we will find that there are 2 electrons, and in p orbitals, we will find there are 3 electrons. So s orbitals, 2 electrons can be accommodated, and in p orbitals, 6 electrons can be accommodated, but here 3 electron is present, it is the half of 6, so it's give the extra stability. So the s orbitals of these elements is completely filled and the p orbitals are half filled, making the electronic configuration extra stable. Covalent and ionic, particularly in particular state radii, increase in size down the group. There is a considerable increase in atomic radius from nitrogen to phosphorus. So from nitrogen to phosphorus there will be a considerable increase in size. Okay. So if you see this table 7.1, you will find that this is the atomic, here is the atomic covalent radius. Okay, this is the covalent radius, and here nitrogen to phosphorus, their difference is 40, and from phosphorus to arsenic their difference is 11, and from 121 to 141 their difference is 20, and from 141 to 148 the difference is 7. So when the covalent radius, there is a considerable increase in covalent radius from nitrogen to phosphorus, so the difference is 40. So it means that there is a lot of increase in atomic radius from for nitrogen to phosphorus, and there is a small increase. Small increase means the difference is less, like 121 to 141 the difference is only 20, and from 141 to 148 the difference is only 7. So it says that the considerable increase in covalent radius from nitrogen to phosphorus. However, from arsenic to bismuth only a small increase in covalent radius is observed. That means from arsenic to bismuth there will be a small increase, like from arsenic to bismuth the difference is 20, from Sb to bismuth, means from antimony to bismuth their difference is only 7. This is due to the presence of completely filled d or f orbitals in the heavier metals. So d and f orbitals, they are the heavier metal members. Also What is the reason for considerable increase in atomic size and small increase in atomic size of the covalent radius? Is due to the presence of completely filled d or f orbitals in the heavier members. Now the ionization enthalpy. So for ionization enthalpy, atomic size is inversely proportional to ionization enthalpy. So ionization enthalpy decreases down the group due to gradual increase in atomic size. So atomic size is increasing as down the group. So that's why ionization enthalpy is atomic size is increasing down the group. That's why the ionization enthalpy is decreasing. So because of the extra stability of p orbitals electronic configuration, obviously the electronic configurations of group 15's elements are NS2 and NP3. So NS2 means there is extra NS2 means full field. So s orbital is full field. This will give the extra stability, and NP3 is also half field. So half field also give the extra stability. So the extra stability of half field p orbitals electronic configuration. So due to the extra stability of half field p orbitals of the electronic configurations and small size, and the ionization enthalpies of the group 15 is much greater than that of group 14 elements in the corresponding period. So in the group 14, in group 15 you will find the extra stability due to the electronic configuration, as electronic configuration is NP2, NS2 and NP3. So s orbital is full filled and p orbital is half filled. So that's why it will give the extra stability, and it is written because of extra stability half filled p orbitals. So due to half filled p orbitals, it will get extra stability. And for the small size due to the small size, the ionization enthalpy of group 15 is much greater than of group 14 in the corresponding period, and the successive orders of ionization enthalpies are expected is given here. So ionization enthalpy means the number of electrons that is taken out from the orbitals, that is the ionization enthalpy. So electronegativity values is generally decreases down the group with the increase in atomic size. However, the heavier metals, the difference is not much pronounced. So the electronegativity of nitrogen is 3.0. Then phosphorus will be 2.1. For arsenic will be 2.0. For bismuth, for nitrogen it will be 3.0. For phosphorus it will be 2.1. Then arsenic will be 2.0. Then antimony will be 1.9 and bismuth will be 1.9. So that's why the electronegativity in general decreases down the group with increase in atomic size. So we can also say that atomic size is inversely proportional to the electronegativity. However, amongst the heavier elements, the difference is not much than of produced. So the physical properties are given here. So it is given that all the elements of these groups are polyatomic. So dinitrogen is diatomic gases, while others are solid. That means the nitrogens are diatomic gases. That means nitrogens are gas, and other elements like nitrogen, phosphorus, arsenic, antimony, bismuth, they are solid. Metallic character increases down the group. Obviously, at first we will find the non-metals. Nitrogen and phosphorus are non-metals, and then nitrogen and phosphorus are non-metals. Then arsenic and bismuth, they are metalloids, and arsenic and antimony, they are metalloids, and bismuth and moscovium, they are metals. So metallic character increases down the group. Nitrogen and phosphorus are non-metals. Arsenic and antimony, they are metalloids, and bismuth is a metal. This is due to decrease in ionization enthalpy and increase in atomic size. So this is due to the reason is that there will be decrease in ionization enthalpy and increase in atomic size. So why the metallic character increases down the group? The metallic character increases down the group due to increase in atomic size. Also, when there will be increase in atomic size, their ionization enthalpy will decrease, because atomic size is inversely proportional to the ionization enthalpy. So the boiling point in general increases from top to bottom of the group, but the melting point increases up to arsenic. So from nitrogen to arsenic it will increase. Then from Sb to bismuth it will decrease. So boiling point generally increases from top to bottom. Top to bottom means means down the groups. Top to bottom means the down the group, but the melting point increases from arsenic up to, but the melting point increases up to arsenic. That means nitrogen, then phosphorus, then arsenic. Nitrogen, then phosphorus, then arsenic is melting point increases. Then up to bismuth it will decreases. Nitrogen, phosphorus. Okay. So except nitrogen, all elements will show autotrophy. So except nitrogen, all elements will show autotrophy. So after this I will read. So thank you. I don't know, though my eyes is paining today, so I haven't shown my face today. So thank you. I don't know what will happen today.